Right, I hope everyone is on board. So we'll be starting shortly. Okay. I think the first thing that we really need to work on now is beginning the presentation and the live event as we had promised early. Great. I don't know why Tata Taveta, they are trying to come up with the link. I wish they should join the already existing link that we shared about the Arduino. Those who are interested in Arduino, I think this will this will therefore mean that we can continue because apparently I'm seeing there are people who have already attended, and therefore we can continue with the whole thing, hoping that others are going to be able to join us on the way. Great. I think about Arduino, we are so excited to share with you the knowledge about real-world programming using Arduino, as you can see. And with Arduino, probably we are going to talk about the foundation of the Arduino. Maybe some of the areas we'll be looking at generally are highlights of what is Arduino, how do you deal with Arduino and stuff like that. But we'll take you through. It's not about probably a very strict procedure or a way of going through. Being the first day, we are going just to take you in a very flexible manner. But it's worth noting an amazing statement from one of the people in the tech industry, that when you add software and hardware, awesome things really happen when code and the machines come together. And this is the beauty of coding using Arduino, because we are bringing two things together. One is software and the other one is hardware. And this is just quite amazing. We'll see amazing things will happen during the course of our training, because we believe that when software and hardware meet together, there's always a beauty, there's always magic, there's always something very, very satisfying at the end of the day. Great. So we'll start straight away with going to our first idea is what is Arduino? What is this thing we're calling Arduino? And as I've mentioned, Andy, we are talking about the hardware, or rather the physical object that we can be able to see. In most of the cases, they are basically the metal or the chip, or you can see electronic boards. So when we talk about Arduino, we'll be talking about the electronic boards that exist. We're also going to talk about the development environment, or the software, or the area where we're going to do the coding. And we're also going to talk about the various support that we're going to have, because when you code, coding is not about you alone. Coding is about something we can collaborate and work together through. Great. So Arduino is about the hardware. Remember that too. Arduino is about developing software, or rather coding, and Arduino is about the community which support you as you move through. There's a lot of tons and tons of material that we are going to share about Arduino, and therefore this one brings us to the hardware part. So what is this thing called Arduino? Whenever we talk about Arduino, this is the common picture that comes in the minds of people, because it is the board, the microprocessing board, that allows us to be able to probably to add some code, or to code it, or to give it instruction to help us solve wonderful problems in the community. Remember, coding is about problem solving, it's about collaboration, it's about creativity, and it is all about doing what we love so much. So this is what we want to go through. We want to look at this board, and we want to talk about the board. That is what we are probably here to talk about. So simply, what is this thing we are calling Arduino, and how does it look like? This is the board we want to discuss during this particular meeting. If you have time. Correct. So let us look at the board keenly. This board, it may be looking like this is the only board we're talking about, but otherwise we have different boards that we have, Arduinos, different types of Arduino. They are all called Arduino. So you may think you may only have one kind, the similar one at the corner here, but which is called Uno, but we have Mega, we have Lilipad, we have Arduino BT, Arduino Nano, Arduino Mini. All these are used in the different projects. It is all dependent on what project you want to pick, and where do you want to start. So that ensure you know that there are different boards. It's not only one board that can be used, and it all depends on the project that you people will be picking. If you think you want to do something probably around the clothes that you want probably to be able to see, then you'll be able to be using Lilipad. Maybe Mega would want to do things that needs more pins. You can see, as you can see, it has many pins. We'll see later how these pins, or rather the areas that allows you to put more wires. That is, if you have a project that requires that you do a lot of connection, then you'll want to go for a Mega or a bigger version of Arduino. Then think about the Nano, which is just so small. Probably your project is just a small thing that you want to really just use to come up with a project that would use this. So again, I want to repeat that when it comes to Arduino boards, everything depends on your project. So it's all about your project that will give you the flavor. Once again, we're just talking about the different boards that exist outside there. So there are many versions, but they differ on size and probably the power or microcontroller. And again, this should be taken that it only differs based on the project that you want to come up with. Okay, maybe let me take you through again and say, this is like the major ones that are always seen. This is Uno. At a close range, we can see the Uno here, and at a close range, we can see the Mega. The Mega one, you can see it's written Mega inside, and then the other one is written Uno, and you can be able to to tell by the way you can be able to see that happening. So there's a mega and there's a uno. So probably it is good to note that they are different. Look at the number of pins. The number of pins are just too many in the mega one, and the number of pins are a bit not that many, because here you can see all the way the numbering goes up to around 53 pins. But here we are talking about only 13, or yeah, 13. So this one tells you that definitely there is a small difference in the number of pins that probably we are going to be using in this particular session. Great. Maybe now I'll go straight to the next one that deals, and I think I've said again, the choice of Arduino that you want to use depends entirely on your project. If you go to the website, and I've been able to pick at least the website here, part of the website I've been able to pick here. It is, again, you'll be able to see the Arduino product, and you'll be able to see the Uno, the entry level, especially when you're beginning. You'll be able to look at the entry level, and the levels are here. The Uno, there's Leonardo, there's 101, there's Explorer. All this, there are so many. You can see there are so many Arduinos that are being used in this particular. They're all found in the website, and there are others which are being developed as we are speaking. Great. I think maybe after that, let me now take you straight that Arduino. If you look at it again, it is about, it's the board, and you can see there are so many pins inside, and there are also pins the other side. There are, in fact, for the Mega, there are pins all around, and this one tells you quite a lot about these pins. Probably I may not be able to draw, but I think it is good to note that there are pins that can be used probably to, let me probably get some point the pen here so that you can be able to see. These are the pins I'm talking about, and these other pins are here. You can see, and for the Mega, you can be able to see these pins. There's so many pins around here, these pins, and then you can be able to, if you are able to read closely, you will be able to see that there are others which are basically written like analog, and the others are written digital. So we want to see what is this thing we are calling about analog pins, digital pins, and all that. But remember, everything in Arduino, we are talking about analog and digital. Remember, when you talk about real world and adding now software and hardware to come up with to come up with something working, definitely we'll be talking about analog and digital signals. So here we are, as we have talked about the analog. Let me now talk about these things of input and output. So Arduino, whenever we are doing programming, definitely we need to have inputs, and the inputs here are probably the commands we are giving it, or maybe the signals that are going into Arduino, or whatever thing that Arduino is picking from probably the environment. Whenever you are writing a program, remember, it's all about the commands that are going in, and then the impact or the outputs are actually what you want Arduino to do. So whatever, depending on your projects, we'll be very careful to look at the inputs. So we'll be able to help you how to design and program inputs. At the same time, we are also going to support you in how to design and program output. Like we know Arduino you may want to do a project around probably farming. Let me give an example of farming and smart farming. What do you want Arduino to do? Probably to be able to detect how the plants are doing. What is the temperature in the planting area? What about the humidity in the soil? Think about anything that probably happens in the farm, and bring that information as input to Arduino. Then output, what do you want to happen? If, for example, the farm is in an enclosed area, you may want, if it is too hot, you want the fan to move on, the fan to be turned on so that at least the whole thing becomes a bit cold, or the temperature is regulated, or probably you want an alarm, or probably you want the water to be irrigated, automatically the water to be poured so that the plants are getting to be watered automatically. Those are the things we're talking about, the output and the input. So the input here in this case is the information we are gathering from the farm. What is it? Is it the higher temperature and all that? And then the output is, what do we do? The reaction, what can we do whenever this thing really happens? So those are the things we want to see. Let us all just take it literally like that for now. Probably later we'll be able to see it in a different way. So we are talking about generally the output and probably the input. We have talked about that, and at least it's very easy. It's very, very important you really know that the whole concept of programming hardware or real world object is to be very keen on ensuring that you capture whatever input goes to the microprocessor and whatever output that comes out, so that you know what actually will happen, the activities around it. Maybe we'll learn a lot as we go. This may not really make a lot of sense for now, but let me pick the next tool. So in Arduino board, definitely we are talking about digital and analog input signal, and then digital and analog output signal. So you will run a project that requires that you put input that is digital or do an output that is still digital. Probably something that's turning on the light, which is probably digital, or turning off the light, or putting on the water, or making kind of noise louder or softer and stuff like that. So all these things will come into your mind when you see an Arduino in a particular way. So, and the whole thing is done. I want us to go back to the board and see that what really translates and gives meaning to all these things I'm talking about. Probably you put this board inside a smart farm and you are expecting it to receive the digital input, okay? And then this digital input, you want them, you want to use those inputs to do something. When you're doing something, then output is expected to come out. And what really processes all this? What is the power? What is the brain in this board that enables this one to take place? And that is where we are coming up with, you have to really need to know the microcontroller, this long thing. I think maybe in some Arduino format that probably you're going to have in school, as soon as you get this object, you may find that this is not the way it is. Probably it is smaller than this long one. Maybe this is too long, but the other ones are probably smaller. But all in all, there is a microcontroller, like the brain that processes the input and then brings out the output, the desired output, and all that. And all this they are going to start making sense as we look around. Let us also probably look at the other parts of the board that you may want to be able to see. Remember, this is more of an overview, an overall overview, and a very a bigger picture. In our upcoming webinars, we are going to go into detail on especially the coding and what really happens. So in the real picture, we can see this is the Arduino. There's a USB port. I think this is where definitely, as we are going to learn, is where we can power, and we are going to use it as a USB to connect to the computer, where we're going to write the programs and then upload those programs to the board using the port. Then we have the controller. We talked about the microcontroller. This is the one that processes the whole thing, as you can see. You can see it here. This is the one that processes the whole thing. We've talked about that. Then think about other things. I think we've talked about the pins. So you can see these pins are here. There are all number of pins. There's so many pins here, but particularly we have just taken these ones that you've seen, the ones that have been indicated in yellow. Those are the digital pin, and you can see they are 14 in number because they're starting with 0 all the way up to 13. Then we also have probably another thing that I really need to put across. The other pins are on the opposite side, which are analog, and then we have power pins, and then we have the power input. Probably in the later slides, we're going to really show you this in detail. Great. I think maybe we go to the next, and we'll be able to pick in probably each and every. I've talked about the USB port. That one is used to upload when you want to upload programs into Arduino, you use it. Sometimes if you don't have the software to upload, probably you'll want to use it specifically as the power source for you when you connect it to the computer. So it becomes the power source. That is the USB port. You will see it in many space. Great. The next one is, of course, we want to look at there's a button on the board. This is usually for resetting the board. In case things are not working, you can reset the board to the default, the way it looks like it is new. Again, there's that reset board. Then another thing, again, that you really need to find about in the board, you'll also look at the voltage regulator. This one over here is the voltage regulator, because you never know the kind of power you are putting in to the Arduino board, but whatever it is, this is the regulator that really checks the voltage coming in. And then we have the power connector. In most cases, some of your project will require that the Arduino is taken away or disconnected from the computer, so you'll have to look for a power source. The power source can be the battery, or you can get it plugged into the wall to get the appropriate power with the appropriate adapter, which I think we'll be able to show in further videos. So I think that one would be good to work with. And then I think maybe the next one we'll be talking about is the digital inputs, as we've talked about the pins. We've talked about the pins. In the normal UNO, I think this is the one which is in the schools, or which you'll be using in your projects, but you're not limited to taking others. Remember, this is for learning and for education. You will actually look at all these pins, and then they begin with the 0 and ends with pin 13. And these are the pins that are called digital pins. So you will plug in baby gadgets or components that are digital in nature. And then, but one thing I want to mention, that these are just referred to as digital, but you can see even the others that has some small tilde sign on them, you can also connect others around them. Great. Maybe I think the next one is looking at the analog pins. These are the pins that I use to connect gadgets that require analog. Analog, I think maybe it's in the next video I'll be talking about, in the next slide I'll be talking about what analog and probably digital would actually represent or mean. I think very fast, so that at least you know the digital and analog, the difference between digital and analog things. When we talk about digital, we are actually talking about all physical things, the ones you can touch outside. They are basically, we calling them analog. It means that the value is either minimum or maximum. It's either on, I mean, they have minimum values and they have maximum values, and all along there are various variable values that can be seen all along the way. For example, temperature. When you look at temperature, temperature can be either 1, 2, 3, 4. So there are many values. When you talk about analog, we're talking about a a range of values. But when we talk about digital, we're talking about either only two values, either on or off, or we are talking about either on or off, or 0 and 1. And in the example that I'm putting here that can really give you an example is in the alphabet we only have 26 letters. So there's no letter between A and B. It is either A or B. It's either C or D. We can't have a letter in between. That one has not been there as much as probably we want to have. So that is where the idea of digital comes in. Great. I think maybe these are just, again, high-level introduction to all this. But the moment we start working on projects and giving you hands-on, we will be able to show you much about this. Great. Probably I'd want to give a break and look at probably some of the questions that you've really shared online, and then probably I can continue after a break or maybe 5 minutes. Then we can look at more aspect of the board, because today we just wanted to talk about the board. We are back. Apparently, the question, what is the importance of Arduino? Okay, good. I will be answering that shortly. Thank you, Stacy, for asking such a wonderful question. That is Stacy Masconde. Probably another question that is around here. The importance, I think, what is the function of Arduino and all that? Okay, good. I think that's what we are going to next. At least you have now seen the board. We have known the board mostly, and we are going to take you to that particular level. It's good that you're asking such brilliant questions. Good. So we've talked about the different parts. I want to bring your attention to this. There's also another component on the board, which is green LED. There's a light, that light emitting diode. You'll find it somewhere here. This just to indicate that the Arduino is powered. It is on. It has power. Its power is reaching it. So you'll always be seeing it there when it is okay. It is there. Then probably we go to the next one, which is basically you can see the yellow. They're also light emitting yellow. You'll see this yellow thing. This one always happens whenever there's data exchange. Either the data is being exchanged from probably one item to the other, or maybe the data is coming in, or whenever you're uploading your program, which is called Sketch, as we'll learn later, you will see these lights blinking. They naturally don't really have to be on all the time, but you'll see them making some kind of a blink, turning on and off immediately to show that data is getting in, or there's a bit of communication or taking place. Great. The next one, I think, we'll be talking about this other light. Also, you'll find it here. It is always connected to pin 13. So this pin and this LED are all connected. So you might always see the two. They are always connected. So this one will be lighting. So if you connect to pin 13, if you are connecting your project and you're connecting on pin number 13 here, definitely know that whatever the thing, if you are connecting maybe an LED to light or something to put on and off, you'll always see the effect on this LED or this lighting emitting diode. This is particularly put here to work to indicate to you that probably your program is working as desired. So you can use it many times to debug or to remove an error from your already working program, as you are probably designing something or programming something or coding some aspect. So this is very important. You can be able to know that. I think maybe somebody's asked about Arduino, why Arduino, or what does Arduino do? And there are definitely things that we can talk about Arduino, that especially the microcontroller. Where are they also found? Maybe somebody can look at that and see. I like comparing what this chip. This is the brain that is in the Arduino, and you can see it here. This is the brain that is in the Arduino. You can always see that one there, and let me put whatever. But apparently the same brain that is in Arduino, the one controlling that you can use in Arduino, is also in the robot that you probably some schools are already having this Lego Mindstorm robot. It is actually inside there. It's the one that also controls the robot. So it means, therefore, whatever you can be doing outside there with the robot, which already has been simplified for you and given to you in small, but again very limited, now you have an open way of doing it right here in the Arduino. As much as we can see the robot, this other side, these are the robotic things like Lego Mindstorm, which is already there. Some of you have already interacted with it if it is in your school, but if it's not, you may interact with it. But in most cases, you'll find that Arduino offers more opportunity than what we have, because this one is limited to the various parts that has been given. But with Arduino, you can use the same brain. It's like now giving you the brain that is inside this robot and putting it open and accessible for you so that you can do anything with it, so that you're not limited to the ability of the components of the already these kinds of robots that are already set up. You can only do up to a certain level of activities. You can only give up to a certain level of commands. But with Arduino, you are open to do anything. And anything here, I mean, anything, because this is a very powerful chip, and it is very powerful to an extent that probably I'll just try to, as I answer the question of Stacy, is that it is so powerful to an extent that you can use it in all these areas. It can be used in the agriculture sector, maybe to control the kind of farming. Maybe, you see, right now we're talking about rain. Rain as the only way. Most of the farming are dependent on rain. What about the climate change problem? There are problems. You can decide to automate the watering of plants using Arduino. You can use it in the car industry, vehicle, to do something to detect probably thieves and stuff like that. Maybe most of the system you see in the cars are made out of the Arduino. Construction industry needs it. In the entertainment, you cannot say you don't want it there. Probably healthcare also needs a robotic kind of a thing. So when you're talking about Arduino, definitely you're talking about robotic nature of doing stuff. It's like a robot, but now it's open for you to create it. You don't have to give it an exact figure or probably an image of the robot the way we know it, but you are free to use it on anything. Household purposes, I don't know, whatever system you want to make in the house, maybe a very smart door or a smart bathroom that cannot probably open the water if the stranger is the one who wants to take a shower and stuff like that. In the laboratory, we can have them. Think about things, even the airport, security, all this. There is a brain, there is a microchip running to process the information they are given, so that the intended things are put together. So I think maybe we have done much, and I want to probably take you to maybe the notes which we have shared about Arduino, and it is important that you get them, some of them here. Great. Maybe these are the parts of linking and connecting. This is usually a simple way you can be connecting Arduino to other things. You can see now here we have other components which we'll be talking about in our next webinar. We'll be talking about these other components that are found in the Arduino kit, be it the light, be it the resistors, the small screen will teach you how to program them so that you are able to get them, and even how to connect them to the Arduino board so that they are connected and they are able to give you the desired program. And I've also shared with you, and I think this is already in the program, and I think it's already in your. I shared with you in Teams a lot of information about Arduino and what you can do with it, because somebody is asking what can you do with Arduino, and I want to show you just a page. I think it's page 11 in the notes that we have done. So probably I'll stop sharing this, excuse me, so that I stop sharing this, and then I share with you another one, probably that you'd want to, you'd really wish that we share. Let me share with you this, and correct, I think, good, it is coming live for you. So you can see here we have an Arduino that can follow you. It's a drone that follows you. You can do LED cube. This one you can get all this information. This note is already there. Probably a car, sort of the light following robot. So you are free to use it. Okay. So I will be checking on the questions, and there are so many questions. Wow. And now probably because of time and also the questions, I'd rather wish we just have it up to that level of knowing what Arduino is and how do we connect to Arduino and all that. I think that one we should do it in the next webinar, where I will be showing you how to really take use of how do you connect all these other components that come in the Arduino kit to the Arduino itself to be able to do simple tasks for you. Meanwhile, let me take this opportunity probably to answer some of the questions that have been said, because time is not going to allow us. By 4 will be by 4:30 we should be done. So probably if I give 15 minutes to asking questions and then other 15 minutes or maybe 5 minutes just to wind up to do a summary, it will be good on our side. Great. Allow me to go back to the presentation and probably get, I don't know whether we got it right. Not okay. So as I've said, Arduino can be used in all that. Now let me read these questions very quickly for all of us to get. Maybe I may want to put them online so that we can be able to look at them together, and probably when we are answering, we are able to answer. Let me just. All right. Okay. So. Let me get a clean page here. So, and probably insert text so that I want to try as much as possible to address some of this. So another question is here. Will our project dictate the type of Arduino we need, or all Arduino boards have the same components? It's a very good question. Yes, your project should dictate the kind of Arduino board you need, especially if you need, it can be a very small thing you need, but otherwise what we have recommended, we recommend Uno. Uno has always done everything. I want you also to know that all Arduino boards can do everything you want them to do. However, sometimes if your project needs so many connections, then you need a board with so many pins for you to be able to connect. If your program project probably it's just a small thing that really can be put on a cloth, and then therefore you don't actually need a whole big thing to be working on. I wish I had this photo of Arduino on cloth. So maybe it's just a button. So with a button, you need a lily pad. You don't need the whole Uno because Uno is big. So, but for your work, you just use Uno, and then now when you want to translate it to the actual that you really want it out there, then you think about using that. Again, from Robert, because I think this is now from Robert. It says, once the project has been programmed, let me put it here for you to see. It says, okay, once the program has been, and let me put bullets so that at least, because these questions are very important. Once the program has been programmed using Arduino, will the project continue working if Arduino is disconnected? Arduino is the one that is running the project, because the brain of the Arduino is the one that helps working with Arduino. So definitely, if you want the project, you want now to package your project for the market, then you can either put the whole thing into some sort of a package or an enclosure. So you can do a plastic enclosure which can be printed in 3D. You design it and it is printed, and then you have to put all these things inside, because Arduino is the one that's running with it. Or in another way, there are people who use this. I think you've seen the ATM Mega, the one I've just been showing you. They plug it because it's pluggable. You can remove it from the from that place. You can remove it from the Arduino and put it aside, and now connect those things. Already once it is programmed, you can now use it to package so that it becomes lighter. But otherwise, you need the brain to run the program for sure. You can't do without the Arduino running for you the program. Great. Okay, another question that is coming here. Where can I get workable projects for mathematics using Arduino? Any link? Oh yes, there are quite a number of links that we are going to share. I've shared so many. I've shared so many, and I think we'll be sharing with the teachers, and even you. I'll share with you the links. I think maybe these links here are not probably, you cannot be able to click them, but I'll put a list of links and share with the teachers, or put them down. If you are going to, if we put this video on the YouTube, we'll have to put all the links under the description space so that you are able to click and just go to those links and be able to do. Are light emitting diodes available in the market freely? Yes, there are so many in the market, and I think they are costing 2 to 5 shillings, maybe 2 shillings to 5 shillings per LED. It all depends where you get them from. Once the project has been programmed, I think that one we've answered. Then another, where can I get a workable project? That one I've said. Hello, are all Arduino boards the same? I mean, do they have the same components? In other words, will our project dictate the type of Arduino we need? I think that one we have said. If you, the power may not be the same in all of them, but you will actually need all the type that probably works for you. In this case, we are talking about, I think I've given you the examples here of different Arduinos that we are working with. There's Uno, there's Mega, there's Lilipad, there's Mini, there's Nano, there's BT. So think about whichever you want to use, and it all depends again on the project. Lilipad is mostly used when you want to have it stick, your project stick on a cloth or on a material which is a bit fabric sort of. You need some small, it's a small button. So once you program it, it goes with it. So it depends on your project for sure. So you don't need, even this Mini, they are used for something. If you find your project can be run by Mini, go with it. There's no problem. I think, by the way, Arduino is equivalent to a 286 computer, a whole computer of those days. So it is very powerful. It can do amazing things when you use it. Maybe I'll look at another question. What's the function of Arduino? I think I've answered that. Arduino basically is used to help you program hardware or real world, come up with projects that are real world in nature, and you can do much. Remember, learning how to code using Arduino only opens your career. There are so many careers that are around Arduino board. One is probably electrical engineering. That is there. Engineering itself is around there. Probably robotics are there. Things to do with maybe artificial intelligence. All this, they are all around Arduino boards, and definitely the future is so huge when you are learning how to code Arduino. And remember, we talk about Internet of Things, and everything nowadays is Internet of Things, and we'll need people to be able to assist us in the Internet of Things. I don't know why you say you didn't see, you're not getting, but I think maybe, I don't know who is saying that they can't get me. Okay, great. Great, I think maybe that is good. Maybe there's a small technical error for others, but everything from my side looks fine, and I have a team that is confirming that the sound is okay. The sound engineer is confirming to me that the sound is perfect. Great, I think maybe to wind up, because we have like 10 minutes and we'll be stopping. we just to take you back to what we've done, we've actually looked at the Arduino, the board itself, looked at the various parts of it, and for today it's just introduction to Arduino, and I think that was enough. What is Arduino? What do we expect? But remember, some things happen when Arduino works when you add software with hardware. Probably there are even other things that I want probably to show you. Let me show you this website. It's called microchip.com, and you can see the amazing things that already Arduino itself is doing, and we can probably stop sharing this, and then I can share with you this other one, and you can see the real-time things. The vehicles need that. You need a parking engine. You need that. Inside the car, there's a lot that probably can be done by the Arduino chip. Inside the house, from the security to the fridge to the lighting, all that can be done. Imagine the fan or movement sensors in the house for the security. You have every other output, even the brush that we use. Some of the brush can be made to brush automatically. So think about the opportunities that you have around Arduino, and I think I also wanted probably to share with you this is a big community where you can get projects that have been done, and you can learn from this, especially those that deal with Arduino, which are so many here. There's so many projects done with Arduino. You can imagine somebody doing an open cart, automation flow cooler, all this IoT-based notification system. So it's upon you to decide what smart thing do you want to create with Arduino. And you can imagine some smart things Arduino switch. So you can even create for the Samsung companies. All these people are doing amazing. Now you can even see this guy who's talked about creating a glove that translates sign language into text and speech. So think about that. ECG monitor, all this. So I think Arduino can do tons and tons of things. I had to show you this because there is that student who wanted to know why Arduino, what can Arduino do, and we have so many projects that are done outside there, which you need just look at them and then customize based on the problem. Remember last week we were talking about problem design and problem identification, and then you ideate and then come up with your own. Then you can borrow a lot from here. But we will also teach you how to code different things from input to output. Great. I think the seven minutes are the ones probably I'm remaining with. If there's any problem, any question, I can be able to answer. But otherwise, you can see this amazing tons and tons of knowledge. And I think this is a small Arduino Mini, and it's also doing something. I think they're showing how it is being used. So you have tons and tons of information to work from. Maybe there's a question, a last question, skills and resource identification, a general overview. Yeah, today it was more of a general overview for sure. There was nothing much. Yeah, for Korea from Masai Girl says it's more of a general overview. So what Arduino board is like and what it can be able to do, you can do everything else. You can build everything, even the ultrasonics side. Anything you want to deal with, you'll be able to get here. Great. Yeah. The questions seemingly okay. There's this lady from Tarumas. Is it possible to set up? Let me read the question. Different timing using Arduino? Yes, it is very possible to set different timing using Arduino because one, That is Taruru from Masai girl. Because definitely, remember with Arduino, we are able to code it, and it's the coding that really determines all the timings and all that. We will be able to instruct them using the code. So it is possible to do all that with the code. Yes. Another question coming in. Oh, this is Esther. So Esther, yes, what are you saying, Esther? Say it. Okay. Great. So I think maybe we have talked about, okay, how do we go about identifying the skills and resources for the project that we want to undertake? Okay, great. I think when we have said one thing, I think there's a question here that I really need to work on to answer very quickly before we top, is that how do we identify the skills and the resources we need for the project we are about to undertake? I think we said in the other previous webinar that the first thing you need to do, first identify the problem, then you can identify once you identify the problem, then go straight to the solution that you are recommending for the problem. Then during the abstract level, because I've seen others have already started sending in their briefs or the abstract, this abstract is what is going to be used, particularly with us, to help you work together to see, do you have the skills? Then you can see if at all your project is about a problem that can be solved by coding using Arduino, then you start thinking about picking Arduino. If you want to do a smart home and you're thinking about Arduino, then you have to start with Arduino. And when you talk about Arduino, definitely we will be coming in to help you with the right skill, especially for the coding. Although we will code, we'll help you learn how to code. Generally, everybody will have to go through the coding skills that we are going to do in our next webinar using Arduino. And then in the other sessions, we'll have now a one-to-one meeting with your team, because based on the problem, the source that you want to, the solution that you have identified, based on your project, will help you to acquire those skills. Remember, we said it is open. There are others who want to even to use far away from Arduino. They want to build a website. When you want to build a website, maybe you may not need Arduino for the website. You only need another skill, which is coding using HTML and CSS. And therefore, the team will just be taken through that. So you don't need to really panic about the skills and the resources needed. And those who want to, I'm aware that there are schools that are trying to work around to be able to, they don't have links on how to purchase the Arduino kit. I think we are going to link you up with the program. I think the program coordinators are going to link you up with the right sources, because most of these things are available, and therefore the schools are going to buy, even if it's one kit or two. Others are talking about two, others are three, but whatever is available, kindly use what is available based on your project. So don't buy what you don't need, especially once you have identified the problem and the solution. You don't need probably Arduino, but this is a skill you need to learn. In future, it will open so many doors for you, because coding robots will be something of the future. If the future will be controlled by automation, automatic car, when you get to the car is smart. Like now, you see, get into the car. You can't drive a car if you're not the owner of the car, because the car may listen to your voice. The car also identify your eyes. The car is always with you. So I think maybe we need to find that. We will follow up and help you get the resources and the skills as per your project. Kindly hand in your abstract, kindly hand in your briefs about the project, and we'll be able to guide you from there. I want to stop there, saying today we just wanted to look at the board in its overview, very high overview indeed, and then inspire you to begin being curious about Arduino. And then the next level will be, the next time we'll be talking about how to connect Arduino to the various components that comes with the kit. We'll learn other things that you can connect to, so that you come up with simple projects that we are going to do. One is coding the inputs, then coding the outputs. Those ones, as we have said, input devices and output devices. We will want to see how we can be able to use them. Otherwise, thank you so much for listening, and I'm glad we did this together. Continue asking questions. The video will be available and the link will be shared for you to be able to listen to this again and again and keep looking at it. Thank you so much, and may God bless. You are free to leave now, otherwise the meeting has just ended.